In this section, we'll be discussing solving inequalities. Inequalities are any equation that involves the inequality symbol. An inequality symbol would be something of the form less than or equal to, greater than, or greater than or equal to. So any equation that involves these signs instead of the equal sign is going to be an inequality. So we're going to look at some inequalities here, and we're going to talk about how you can show these solutions in 3 different ways. So let's say I have an interval, and I know that a solution x can be any number in between -2 and 3. Well, on the graph, that would look like this. So I've got -2 and 3 on my graph, and I'm telling you that x can be any number in between those 2 values. So x can be any number in between those 2 values. So I would shade all of the area in between -2 to 3. So x can be -1, x can be 0, x can be 1, x could be 1/2, x could be 3/4, any number in this red shaded area. Also, by the looks of this inequality, it also says, since it's a rounded parenthesis on the end, that indicates that the endpoints are not included. So -2 and 3 are not included. So x cannot be -2, x cannot be 3. In an inequality, we would simply just say that x is less than 3. We also would say that x is greater than -2. In other words, x lies in between those 2 numbers. If you look at them as independent inequalities, this one here says x is less than 3. You can see that x is definitely less than 3. And if we look at it from this viewpoint, we could see that x is greater than -2. And you could see that here, x is greater than -2. You always want to make sure that these signs are pointing in the same direction. All right, let's look at the next one. This time it's the exact same numbers. However, by the look of the brackets, since they are squared, that means it is a closed interval, which indicates that every number in between -2 and 3 is a solution. And since these are closed on the ends, that indicates that -2 and 3 are solutions. So -2 is included and 3 is included. So solutions can be any number in between, and we will include the endpoints, where here they were not included. In an inequality format, we would set it up the same way. However, if we want to include the endpoints, we include the equal sign, saying x can be any number less than or equal to 3. X can be any number greater than or equal to -2. You can do half opens like these next two. We would say x is in between these 2 numbers. In this case, -2 is included, but 3 is not. So we would again shade the area in between those 2 numbers. We will include -2, and we will not include 3. Doing the same thing for the next one. This time 3 is included, but -2 is not. 3 is included, but -2 is not. So we would shade the area in between. -2 is not included, but 3 is. Okay, let's look at some other examples. Here we've got an inequality that we will show for the interval notation that is from 2 to infinity. So I like to look at the graph first. If here is 2, I'm saying that the shaded area will go everywhere from 2 to positive infinity. So it will start at 2 and it will go everywhere from 2 all the way to positive infinity. Positive infinity is out to the right, so this graph will go forever and ever and ever to infinity. Notice we never include infinity. You can't include infinity since it's not a number. It's not an attainable number, so we can't include it as an endpoint. But we can include 2 as the minimum value. So the graph from 2 to infinity in an inequality starts at 2, and it's going to be any number greater than or equal to 2. So we don't say that x is in between 2 and infinity. We never use infinity in the inequality form. We simply just state that x can be any number bigger than 2. So I always like to do the graph first. So if I look at this interval notation, it starts at -3 and goes to infinity. Notice these are always written in ascending order, smallest to biggest. This is the left number and this is the right number, the left bound and the right bound. So this graph is going to start at -3 and it's going to go all the way to infinity. So it's going to start at -3 and it's going to go to the right until we get to infinity. Is -3 included? No, it is not. In an inequality, I say x is greater than -3. I do not say or equal to here because I have a rounded parenthesis, so therefore -3 is not included. For this inequality, remember this is the left bound, this is the right bound. So you're starting at -infinity. Negative infinity is over here. So we're going to start at -infinity and we're going to go all the way to 4. So we're starting at -infinity and we're going to go all the way to 4. And that stops. We will also include 4. To write the inequality, we simply say x is, in this case, less than 4. We will include 4, so we will underscore the inequality sign. X in this next problem says x could be any solution in between -infinity to -1. So this is the left bound, this is the right bound. So we start at -infinity, and then our solution will go all the way until we get to -1. So at this point, here's -1, and we will not include -1. Our inequality will say x is going to be less than -1. We will not include -1, so we will not underscore the inequality symbol. And for the last one, it says that x can be any solution in between -infinity to infinity. Well, on my graph, here's -infinity, here's positive infinity, and x can be any number starting at -infinity, and it goes all the way up to the right to positive infinity. So there is no bounds other than it could be any real number. So the only way we could say this is x is all real numbers. So x is any solution. Okay, so let's use that to solve a few inequalities. For the next grouping, we're going to write these in interval notation. So right now, these are in inequality form. We're going to write these inequalities in interval notation. This is interval notation right here. Okay, so if I were to write this in interval notation, this would be a graph. X can be any number in between -2 and 4. Left bound, right bound. Smaller number, bigger number. Now, what kind of endings do I put on the boundaries? Well, -2 is included, so we will include it with a bracket. 4 is included, so we include it also with a bracket. Okay, another one. This one says x is less than 7, but x is also greater than 2. So in other words, x is in between these two numbers. 2 is not included. 7 is not included. X is greater than or equal to 6. So sometimes it's helpful to look at a number line. If here's 6, x can be any number greater than 6. So this is what the graph would look like. Even though it didn't ask me to graph it, sometimes it's easy to look at the graph first before you write the interval notation. In this case, the interval notation starts at 6 and ends at infinity. So 6 to infinity. 6 is included since it's underscored, and we never include infinity. A lot of students will write it this way, and that would be wrong. The reason why this is wrong is because it's not written in ascending order. We always write the smaller number on the left and the bigger number on the right. Certainly infinity is bigger than any number, so we would never write the bigger number on the left-hand side. For the next one, we have x is less than -3. So if here's -3, if x is less than that, it's any number to the left. So if I were to write this in interval notation, what is the smallest number possible in this red shaded area? The smallest number possible would be this number over here, which is -infinity. And it stops at the biggest number, which is 3. Neither of those are included since we never include -infinity, and we never include the -3 since it has no underscore. Now let's go the other direction. What if we have an interval notation and we're asked to write it as an inequality? So again, if we look at a graph, sometimes it's helpful. This graph says that x could be any number in between -1 to 2. So it could be any number in between. When we write this as an inequality, we would simply just say x lies in between -1 to 2. Sometimes students don't know which way to write the inequality symbols. I suggest you always think of it as two separate inequalities. If you're looking at the graph here, you can see that x is definitely less than 2. So over here, we would say x is less than 2. Over here, if we look at just the left side of the graph, you can see x is greater than -1. So if we look at this side of the inequality, how do we write x is greater than -1? Well, the greater symbol has to be pointing towards the x. X is greater than -1. Also, like I said earlier, the signs will generally point in the same direction. For the next one, we have the inequality we're going to write from this interval notation that starts at 5 and goes to infinity. How do we write that inequality symbol? Well, x is any number greater than 5. Like that. Two more. Let's again write the inequality from this interval notation. This says x is any number in between -2 and 0. Now recall again which way our symbols go. Since x, we know, has to be on the number line, here's -2, here's 0, and we know x has to be any number in between there. If we look at just the right side, we can see x has to be less than 0. So over here, we want to be able to write x as less than 0. Looking at just the left side of the graph, we can see x has to be any number greater than -2. So over here, how do we write x as greater than -2? Well, we point the greater than symbol towards the x, or in other words, they have to face the same direction. Last one. X is any number from -infinity up to 1. So it starts at -infinity and goes all the way to 1. So writing this in an inequality, we would say x is less than 1. So my biggest tip for these problems is to always graph first. Sometimes you'll notice in the homework it'll ask you to do the interval notation or the inequality first and then graph it second. That is not my recommendation. I suggest you always graph first to get from one to the other. There are properties of inequalities. If you look at these inequalities, you're going to notice that you can do certain add and subtracts to both sides of an equation and you'll still have a true statement. For example, if I have 2 is less than 4, well, certainly that is true. Here's 2, here's 4. It is certain that 2 is less than 4 because 2 is on the left-hand side. Any number on the left is always smaller than any number on the right. Can I add 2 to both sides? If I add 2 to both sides, well then I get 4 is less than 6. That is also a true statement. If I subtract 2 to both sides, I get 0 is less than 2. That is also a true statement. Multiply by 2 to both sides of the inequality gives me 4 is less than 8. That is a true statement. If I divide both sides by 2, I get 1 is less than 2. That is also a true statement. So far, I can add, subtract, multiply, and divide both sides of this inequality by any of these positive numbers, and I'll always end up with a true statement. So the things we've learned in algebra so far are still working with inequalities. Let's try doing the same thing with negative numbers. So let's add a -2. So we're going to add a -2 to both sides. So that means I have 0 is less than 2. That's a true statement. Now if I subtract a -2. Now remember, subtracting a -2 simply just means you're adding it. So really all we're doing is adding a 2 to both sides. So that becomes 4 is less than 6, which again is a true statement. Now if we multiply by -2, that gives me -4 is less than -8. Now let's look at that on the number line. Here's 0, here's -4, here's -8. -8 is smaller than -4. And here we're saying -4 is less than -8. So that is actually backwards. It should be flipped upside down. That inequality symbol is going the wrong direction now. So that is actually a false statement. How about if we divide by -2? If I divide this side by -2 and this side by -2, I get -1 is less than -2. Well, looking at the graph up here, here's -1 and here's -2, And negative 1 is not less than negative 2. Negative 1 is actually bigger than negative 2. So that is going to result also in a false statement. So what situations result in false statements? Anytime we multiplied or divided by a negative number, that resulted in a false statement. So anytime we multiplied or dividing by a negative number. Anytime we multiplied or divided by a negative number, that resulted in a false statement. But we can fix that. What we can do to make these come true is, well, we can reverse these symbols. We can get rid of these symbols and change it to the other direction. If we do that, then all of a sudden these actually become true statements. So that's what I'm going to recommend you do to fix these statements. We're going to flip the inequality symbol. So you still do the math on both sides like we normally have done for all of these, but when you multiply or divide by a negative number to both sides of the equation, we have to flip the inequality symbol, so we're still left with a true statement. So we're going to keep our eyes out for something like this as we move through some more examples down below. So here we've got an example, and there's always some study tips over here to the right. The study tips here are simply just telling us to watch out for the flipping of the sign. So we'll keep our eye for those. So let's solve this inequality. We would solve inequalities just like as we would do for an equation, as if this were an equal sign, we would solve this the exact same way. So we've already got x on one side, so we're going to subtract the 3 to the other side. So that's going to give me negative 2x is less than 2. Now notice I didn't flip the sign. All I did right here was subtract a 3. And if you remember up here, we could subtract numbers all we wanted, and we ended up with true statements. So subtracting or adding is okay to do. Many students at this point see a negative and then they get excited and want to flip the sign. Negatives are okay. It's what you do with the negatives. Only when you multiply or divide by a negative, that's when the sign of the inequality changes. We did not multiply or divide. So now we're going to keep going. So now we have negative 2x is less than 2. So we have to get rid of the coefficient in front. What are we doing here? We are dividing by a negative 2. So what happens when we divide by a negative number? We have to change the direction of the inequality. So that gives me x, we're going to reverse the sign, is greater than negative 1. So this is the inequality solution. Okay. Now the question didn't ask me to do the graph or the interval notation, so I'm going to go ahead and do it anyways. If you were asked to graph the solution set, I would graph this inequality over here on a number line. X is any number greater than negative 1. So here's negative 1. So any number greater than negative 1 would be any number to the right. We will not include negative 1 because it is not underscored. If you were asked to give the interval notation, it's super easy to do once you have the graph. The interval notation starts on the left at negative 1 and goes all the way to positive infinity, small to big. We will not include negative 1 because it is not included, and we never include infinity. So I have shown the solution 3 different ways. This is the inequality solution, this is the graphical solution, and this is the interval notation of the solution. All three of these represent the same answer, and you will be asked to show all three types. So we're going to do some more equations here.